Okay, we learned about exterior angles of polygons. Was that today, or was that yesterday, or the day before? Okay, exterior angles, when did we learn about them? Specifically, what did we learn about them? Okay, so the sum of the exterior angles of any polygon is going to be what? 360 specifically degrees, okay? Fantastic. So whenever we talk about sum, that's what we do. What if we talked about each, and we're going to talk about like each angle, maybe we'll even say each exterior angle, and we'll say this is going to be for a regular polygon. What will that equal? Somebody help it out? We're talking about each or an or one or... So each exterior angle would then be just 360 divided by however many sides you have. Okay? So if you're talking about each exterior one, that would be just 360 divided by your number of sides. That only works for regular polygons. It only works for those. And it's when we talk about the word each, sometimes you'll see the word and, sometimes you'll see one, something like that. Each and, one, something like that. Always associated with and. Okay, what else did we learn? Okay, polygon, sum, conjecture, and that deals with interior angles, right?
Sure.
Okay. So the sum, what does it mean?
Doesn't that mean like all the angles on the inside of the polygon?
Okay, what is it equal? 180 degrees, always, right?
Yeah.
I disagree. Oh, n minus 2 times 180.
Oh,
that's
I
right.
I agreed to that one.
Yeah, we agreed to that. So in this case, when we're talking about interior angles, we talk about adding them all together. All the angles on the inside added together would equal this. Okay? What else did we learn? We got interior angles, but what about this each and everything? So like each. Yeah. So each interior angle, this would only be for regular. This would be n minus 2 divided by times 180, all that divided by n, like so. I remember yesterday we kind of created that box and kind of talked about this. So really, those are the things we've talked about this week, right? Is there anything else that anybody found that we talked about?
Can I read you what I wrote?
Sure. Read me what you wrote.
All I wrote was, the things I've learned this week is how to find the sum of interior.
So sum of interior and exterior angles of polygons.
It's also easy to type on. I also learned that.
And there's the window. You basically have your window, right? With like something like this. And divided it like so. There's 4 formulas. I saw a lot of people draw this window yesterday. I saw a lot of people draw it on the paper today. Raise your hand if you drew that window. Maybe not, it doesn't look exactly like that, but that's a big thing to have. To realize basically, hey, there's interior angles, there's exterior angles. These both deal with the sum on top. These both deal with the regular ones over here. And there is a relationship. Okay? For the each or every, or these guys over here with a regular, they just have the top thing and it's just divided by n, whatever it is. Okay? So that's what we learned yesterday, and the day before, and the day before that. So Monday, Tuesday, Wednesday. Okay? Today what we're going to do is we're going to focus a lot more on kites. Okay? Kites. Okay? Now, I'm a big fan of kites. When I was a young child, my family used to fly kites often. My birthday's in March. I remember several birthdays. I would get a kite for my birthday. And we'd go fly. Sometimes there'd be like this, like a regular kite that you picture. You know, it looks something like this. And there'd be like a little tail on the end of it like this. You know, here you are, you're standing here, and you have this kite thing, whatever you're doing here. That's you flying the kite. It's really a big kite. It's huge. So that'd be like that, okay? But then later on, like there'd be more intricate kites. There'd be like cool ones. Like I had one that was kind of circular. It had all these like little things coming off of it like this, and it was actually like an octopus type, and it was really cool. So we'll just do this. There it is. I have it. Okay. Recently, I thought kites were still cool. I still think they're really neat. In the back of my room, there's actually a box kite on the ceiling. It's called a box kite because it looks like, well, it'd be like a box. I've not yet flown it. I'm going to fly it actually here pretty soon. When it gets to be windy again, I really should have done it the other day. I also have another one in my closet that's actually a slightly different shape and everything else, but it's pretty cool. But you know, one day I'm gonna just, my wife and I are just gonna go fly kites. It's gonna be kind of fun. It'll be a nice little date. Yes, sir.
Do you have any steerable kites?
Say that again.
Do you have any steerable kites?
Oh, steerable. I mean, I think you can steer every kite, can't you? No?
You've never seen those? You know, like two-handed.
Oh, I've never done that before. No.
Oh, yeah, we're
Um,
not
Off at Longview, also each year they have this kite festival.
Yes.
It's amazing,
Oh,
and they have kites that, you know, as a person, like you can basically hold on to like a kind of a small kite, but with the wind and everything that's going on, they have to strap these kites to the ground, like anchor them to the ground, and to like a vehicle because they're that big. They are huge. They would probably not fit in this room. And they have ones that twist around and do really cool things. If you have a chance to see it, I don't know when it is. I think it's usually in the spring sometime. And it's over there at Longview College. It's really cool. It's amazing. Yes, ma'am.
Well, it's about kids.
Okay.
Well, I finally got to fly kites. And I was like 8 or 9 when my cousin, she's like a year below me.
Uh-huh.
And it was like, oh my gosh, it's going. And I was like, look. And then we ran into a tree.
Yeah, it's tough. I have some memories of us having like flying kites, and there would be all sorts of weird things that would go on. We'd fly kites, and like one of us would, like, either the cord would break or we'd accidentally let go of it or whatever else, and it would sort of fly away. We'd have to like go chase after and like find it somewhere. We'd be all muddy. We'd have to drive the car somewhere. The car get all muddy, and we'd have to, you know, clean the car before we went home and stuff like that. It was good childhood memories and stuff like that. But today we're talking about the mathematical figure called a kite, though. Okay? Here's the first thing. Do not call kites diamonds. Okay? Diamonds is not really a proper term for that mathematical shape. You may have heard diamond in elementary school or middle school. They're actually not diamonds. Diamonds don't have a specific shape. They can carve them in any shape. It's like saying something's ice. Well, what shape is ice in? Anything you want. You just make an ice cube. It looks like a kind of like a cube. You cut ice. You can make it into a sculpture. You can do anything you want. The same thing happens with diamonds. You can cut them into any shape you want. They actually come out. They actually look kind of like spheres before anything else. So calling something a diamond really is not geometrically correct. And I just want to tell you guys the right things. I'm not going to go about and tell you the wrong things. Okay. So here's some properties, and I really wish I would have been able to get the stuff that we needed for this. I had this kind of neat lesson plan where we'd be drawing angles and stuff. And here's what it was. You'd be given a piece of paper like this. It's actually kind of like wax paper. I'm not sure if you've ever had this before. And with a marker, you'd basically draw some angle on here. Whatever angle it is, I'd probably tell you to make it an obtuse angle. Okay? Then what I'd have you do is I'd have you actually fold the paper in half, like this, like that. And then it's actually kind of see-through paper, it's special paper. And then you would actually trace this exact angle, oh boy, over here. So it kind of looks like that. That's kind of close. I know it's not exact. But with your paper, it would be exact. Okay? We'd unfold it, we'd look at this, and we'd actually name these things. So I'm just going to name this. It's going to be kind of ridiculous. I'm just going to call this K, I, T, I guess what this will be. Oh, E, yeah. Okay. So kite. Okay? And then we talk about the properties. Okay? We talk about the properties of these. Okay? What do we know is the same? Size. Okay? So we would say that this side is congruent to this side. I'm going to write this down. When we say this is, we would say side KI is congruent to side KE. Okay? Something like that. What else? Well, how do we know that? We pull it over, it's the exact same thing, it's just the image of it. And these two sides are congruent as well, right? So we would say, like, you know, ET, which is funny, is congruent to IT, which is also kind of funny. Like so. Okay? What else do we know?
E and I be like same measurements.
Okay. So when you talk about angles, this angle is the same as this angle. So we would say something to the effect that angle E is congruent to angle I. Yeah. Okay. Anything else? Yes, ma'am. Okay, well, say that again. K and E. K, what is it, angles or the? So you're saying side KE is parallel to side IT. I don't necessarily agree with that. Okay. If they were, I think we'd have a different shape. I think we'd have a rhombus. I think this slants like this, and I think this one slants a little bit more up. So I think this, if I was to exaggerate it, I think this one's like this. I think this one down here is actually more like this. But I don't think those are parallel. That's a good idea. I mean, really, it looks like. I mean, I exaggerate a little bit, but these two are, they're not necessarily parallel. Okay, I'm not going to say those two are parallel. That's what you're saying, but that's a good idea. I'm glad you're saying that. Well, that's not true necessarily. We'll go ahead and okay. What else? Okay. What if I actually have this line in here? Does anyone know what this line is called? Okay, it is a line of symmetry. I definitely agree with that. You could name it KT, but when it goes from one vertex to a non-consecutive vertex, what is that called? It's called stupid. That's not right. It's called a diagonal. Okay, this is a diagonal. Okay, so we can talk about diagonal KT. Okay, and what's interesting about diagonal KT is it actually bisects these angles. Okay, it actually bisects these angles. So what we could also say is this angle is congruent to this angle. Okay, how do we name those two angles? Sam, turn around. How do we name those two angles that I just marked on here? How do we say those two angles are congruent? Oh. Can we just say angle K is congruent to angle K? Does that work? No, we don't know what angle K is. So how do we do that? How do you know how to do that? Yeah. Not really? Okay. I think you have to use 3 letters. What do you think?
Angle IKE is angle
Yeah, let's look at that again. Okay, we are talking about K, angle K, so that's the thing in the middle. That's the vertex. But if we start at I, that's over here, and we go up to K, and then we go down. Wait, I'm sorry. And you said over there. I don't think that's right. I think we change these E's to T's, and I think we're good. Okay, so hold on a sec. Oh boy. Okay, so let's try that. So I to K and then down, that'd be this angle right here. And then from E, oh boy, what did I do? EK. I need to change the I to E. I sound like English class. E, oh boy. Oh, E, K, T. There it is. Okay. So then these two angles are congruent. Okay? Because they're bisected by this diagonal. So that diagonal will actually bisect those angles. Okay? Next. What about these angles down here? Those are also going to be congruent. So we put 3 angle arcs to mark that they're congruent. I don't know what happens when we get like 4, but if we put 4 angle arcs for what we do. How do we name those angles? Really similar to these ones above there. What do you think, Brett? ITK. Angle ETK. That sounds good to me. So you start here, you go up, and that's that. Let's talk about this angle here, this angle here. Okay? Those are most of the properties that we're going to talk about with this kite. And all they're derived is basically, this is a reflection. This is symmetry, as you guys were saying, with what we were just working with. I'm going to see if there's an extra property or something in here, but I think that's just about all of them. And we would have been able to use paper and everything and markers and stuff like that with it, but we'll see what happens. There might be one more working with the perimeter or things like that, but we'll talk about it. If you can, when I pass this out to you, there's some properties at the top, some like definitions. I want you to look through them and see if you can define them on your own based on what we just talked about. So again, what I want you to do is, there's some definitions. I want you to see if you can define these on your own. See if you can find these definitions on your own. They are right here. Just take a couple seconds, see if you can do this on your own. Oh, thanks. I appreciate it. Okay. So it gives us some kind of weird vocabulary, right? So let's go back. I want to define just a couple more things for you. I guess I forgot to do it before. This angle right here, or this part down here, this is called a vertex. That'll help. This also up here is called a vertex. Okay? And this is the main diagonal that we look at. This is the one that we would have drawn with our paper. Additionally, we could draw another diagonal here, which looks like this. And kind of a weird property when you look at this, and it makes sense if you were ever to build a standard kite, is that these two are actually perpendicular. Okay? The weird thing is this does not get bisected. This does not get bisected. Those two are perfectly fine. They're not bisected at all. If they were bisected, you'd actually have a different shape. So it's kind of problematic. For the top and the bottom angles, the K and the T in this case, are called vertex angles. So let's take a look at this. The non-vertex angles of a kite are what? So if we're talking about this picture over here, we're talking about E and I. Those angles, what do we know about E and I? Those are congruent. So let's write congruent. That's the symbol for congruent, which means equal. Angles are equal. Andrew Palmer. Kite diagonals, conjecture diagonals of a kite are. What we're going to do is, I could say two different things here. One I could say is, well, they're not congruent. I don't know how useful that would be. Because they're not congruent, they're never going to be the same length. But I think the more important thing to say is, hey, they're perpendicular. Okay? That means they form a 90-degree angle. Okay? The kite diagonal bisector conjecture, wow, that's a mouthful. Kite diagonal bisector conjecture. It almost rhymes, but not really. So the diagonal connecting the vertex angles of the kite is the blank blank of the other diagonal. Blank blank. Okay? Well, what do you think the word bisector means? Yeah, it cuts them in half, right? Remember that? Bisector, bi means two. Sector means like two sections. So it's going to cut it in two exactly the same pieces. So what we're actually going to call this, a perpendicular bisector of the other angle, of the other diagonal. So if I was to go back to my picture, perpendicular bisector, we look at this. So what that does is actually, if I create another point here, let me make this S, so we have like pipes, I guess. I make this side right here, I have 3 marks on there, it's going to be congruent to this side right here. This little piece, ES, is going to be congruent to SI. Okay? So it's yet another component of kites. Down here, the kite angle bisector conjecture, the vertex angles of the kite are blank by a blank. Okay? They would be bisected by a diagonal. Okay? And what that means when it talks about the vertex angles, those are the angles of the top and bottom. Remember how we talked about how the angles of the top were congruent and the angles of the bottom were congruent? That's basically what's going on. Okay? So there's a lot of information up here. This is the only one that I'm not even sure what we're supposed to put there. So they are perpendicular, but we kind of talked about that right here. They aren't congruent. I don't know if that's really useful. Okay, let's look at how this applies. They're going to give us tons and tons of stuff, and we basically need to figure these out. So if we look at this kite, if we know BC is 12, what can we say about CD? It's also 12. If we know this is 20, how long is AB? 20, okay? It asks for the perimeter. How do we find a perimeter? Add them up. So we say 20 plus 20 plus 12 plus 12. And that says, Silas says it's 84. 84 what? Centimeters. That's pretty easy. We can do that. Okay? With angles.
64.
Oh boy, that's what happens when people just tell me answers. 64 centimeters. Still centimeters, right? 64. Excellent. Thank you. Okay, let's look at this. Here's another kite, and the kite's lying on its side. Like there's a kite that's fallen down, maybe. Okay? Which angles up here are congruent? 46 and y are. This is 146 right here. So I can just say, hey, y equals 146. That's a piece of cake. Can I say that x is 47? No. Usually you'll see this guy up here is going to be bigger than this guy over here. So how do we figure that guy out? Yes, that's exactly right. Earlier this week we learned that, hey, 146 plus 146 plus 47 plus x has to equal 360 degrees. We learned that. Why was one reason we learned that? Well, maybe for this. Okay. So all the interior angles sum together to be 360. When I simplify this, 360 equals x plus, what's this going to be? I'm sorry, 339?
Yes.
Okay. When I subtract 339 from both sides, x equals, what, 21?
Yes.
So there's my x, there's my y, let me put this over here just to find it as well. Does that make sense? That's kind of what we've been doing this week already. Well, let's look at all this stuff. Okay. There's a lot of stuff going on in here. Okay. These sides are congruent. Where do you guys want to get started with this? Yeah.
At the bottom left should be 29.
Okay, so if this is 49, this has to be 49. I agree with that. Okay, this has to be 18 right here, you're saying. So it looks to me like this is also 90 degrees. Can we figure out x? Let me make this a little bit bigger. This is what our triangle looks like right up here. There's an x up here, and that's 90 degrees, and this is 18. Can we figure out what x is? In a triangle, what do they all sum together to be? 180. So we basically take 180 minus 90, that's going to be 90, minus another 18, and we're at, what, 72? So that's going to be 72. And I probably should have shown some work on that. Yeah, you would say, if I was to show work on this, I'd say x plus 90 plus 18 has to equal 180 degrees. Triangle sum. Be x plus 108 equals 180, x equals 72. Okay. Second thing. Let me label this on this picture here. We know this is 72. And I want to look at sort of this triangle right here. Okay, is that a triangle again? Yeah. And if we were to add up all the angles, we have one angle here, we have one angle here, we have one angle here. These are not supposed to be congruent. We would just say 72 plus 18 plus y, so that's one of the angles, plus 29. That also has to equal 180 degrees, does it not? So all I'm doing is I'm saying, hey, this angle down here, this angle right here, this angle here. And this angle it spans a whole bunch of, it's both the 18 and the y. Yes, ma'am?
Wouldn't it be easier?
It would be easier to do it that other way, wouldn't it?
Yeah.
Okay, let's do it that way. Okay, so what she's saying, I don't even know if she said it out loud. Then she looked at this angle, this triangle, and said, hey, there's a 90-degree angle, let's just do that. Right? Let's do it that way. So y plus 90 plus 29 equals 180. I'm okay with that. Y plus 119 equals 180. Subtract 119 from both sides. What does y equal? 61. Thank you very much. that the end of the first page? Okay. Let's look at the back page. This is getting a little bit more complicated. I know this isn't a very good picture. Look how ugly mine looks. It's all blurry. It happens. Okay. It tells us a whole bunch of information, doesn't it? It says label the kind above to reflect the information given. Okay? It says QT is 4, so I'm going to label this part right here 4. Know that. It says PT is 5. That's right here, that's 5. RS is 12. RS is 12. PQ is 6.4. Angle QPT. So I start at Q, I move over here to P, and I go to T, which is right here in the middle. I mean, this angle right here, this is 35 degrees. Angle QRT, so starting here at Q, going over to R and going over here to T. This angle here is 18 degrees. And angle RQP. RQP, this whole thing here is 78. Let me show this up here. 78 degrees. Okay. So that's the given information. Now we have to see if we can include anything extra. So it asks for QS. Can we figure out what QS is? Yeah, because these two are bisected. If that's 4, this has to be 4. QS is 4 plus 4, so that would be what? 8. TS, well, that's 4. We just figured that one out. Because if we know what QT is, then we can figure out what TS is. Angle QPS. Can we figure out what that is? Yes, because this is 35 degrees, we can say this is 35 degrees. So if we add this together, that'd be 70 degrees. QRS, well, this is 18, this one over here is 18. That's kind of the beauty of it. We know half of this, figure out the rest of it here. So 36. PR, can we figure that out? PR. Okay, so if someone said, hey, if this is 5, then the other part has to be 5. Is that right?
No.
I don't think we know how long TR is. I don't know if we can necessarily figure that out. I could probably mathematically figure it out using Pythagorean theorem or something, but I don't think that's really what it wants us to do. We don't know what it is right offhand. So I'm going to say, because it says, find each of the following, if there's not enough information, right, cannot be determined. That's the wrong thing to write out. Let's write CBD. Cannot be determined. That sounds okay. CBD. Or cannot be determined. Okay. Angle QTR. QTR. Can we figure out what that is? QTR. What is that? 90 degrees. That's easy. Okay. Angle STP. STP is right here. That's also 90 degrees. Angle PST. PST. Can we figure this one out? The small angle right here. Not half of 78. I can tell you that much. I think this, we can say this whole thing right here is 78, but I can't tell you how much that small part is, so I think it's another cannot be shown.
Didn't you solve for 180?
Oh yeah, hey, we could do that. Hold on, yeah, let's back this thing up. If you look at this triangle right here, what angle is that? It's PST. That's equal 180 degrees. This would be 125 plus the measured angle PST equals 180. So the measured angle PST equals 55. 55 degrees. Okay, well that part's 55. How big is that smaller part? Can we figure that out? That's 55. So that would what be 23 degrees? We don't even know that right now, but it could ask for that.
Why is it 20?
So these two added together have to be 78. Looks like 78 over here. Okay, what's QR? This has to be 12 because this one's going to be congruent to this piece here. That's 12. And what about PX? 6.4. 6.4, that's right over here, 6.4. Okay. At the bottom of that, it does ask for the perimeter. How do we figure out a perimeter? Yeah, we basically say, yeah, it's 12 plus 12 plus 6.4 plus 6.4. What does that give us? 36.8. It doesn't give us any units, so we really can't write any units on it. What does the last question say?
I don't know.
Excellent.
What was the answer?
36.8.
24
And one side is 28. Look at this, this is 28, this is 28. These are going to be the same. So could we basically write an equation for this? We could say 28 plus 28 plus 2x equals 136. And we could solve this, right? This would be 36 here. Equals 136. That'd be 100 equals 2x. Or x equals 50. So I guess both these are 50. I just really draw it to scale, but that's what we say, yeah. Okay, you guys have your homework. It's on the next page. It looks to me like there's about 11 problems. Guess how many we're going to grade tomorrow? All 11 of them, okay? So be ready for that. If you need help, come talk to me or watch this video online.